Hello everyone, my name is Purnima. I'm network engineer at Capgemini. The demo is about the update on Sonic project regarding network traffic monitoring. The presentation is about traffic analytics for Sonic network devices using sFlow. In today's demo, I would like to discuss about demo objective, introduction to sFlow, sFlow network monitoring demo setup, monitoring setup configurations, requirements mapping for sFlow RT and Grafana, challenges faced while setting up sFlow monitoring, and conclusion. The objective of this demo is to demonstrate the performance monitoring capability of Sonic-based network elements using sFlow, where sFlow, which is used as an industry standard technology here, and sFlow, which is used to by the end users to constantly monitor the network and allows the end users to deploy the analytical tools to perform the deep insights of the network health. The next slide is sFlow introduction, where sFlow. Firstly, sFlow. sFlow enables the application to monitor sonic network elements in real time and acts as a catalyst to perform network analytics. sFlow, which is primarily used to monitor the traffic in network devices. The two main components of sFlow feature are sFlow agent and sFlow collector. Firstly, sFlow agent. The primary function of sFlow agent is to sample the network traffic and sends this network sample network traffic to sFlow collector. Here, sFlow agent is configured on Sonic network element, which is Sonic switch. The next component is sFlow collector. sFlow collector, which is used to receive the data from sFlow agent and store the sFlow generated flow records. The next slide is sFlow network monitoring demo setup. Here, the setup is made in a way where in Linux PC we have installed network traffic generator, which is T-Rex, and network monitoring tools sFlow RT, Prometheus, and Grafana. Firstly, T-Rex. T-Rex is an here we are using T-Rex in order to generate the network traffic, which is an open source, low cost, and stateful and it generates the stateful and stateless traffic. Next, sFlow-RT. The sFlow-RT, Prometheus, and Grafana are the network monitoring tools, where sFlow-RT, which collects the data from the network elements, and it monitors, analyzes, and visualizes this network traffic. Next, the next tool is Prometheus. Prometheus, which is used to store the collected data from sFlow-RT in real-time database, and the Prometheus collected data will be in the sFlow-RT in the form of sFlow-RT matrices. The next tool is Grafana. Grafana, which is used to see the collected data in different user friendly dashboards. Here, for our demo, we are considering the already existing sFlow-RT Grafana dashboards, which are sFlow-RT health dashboard, sFlow-RT network interface dashboards. So, firstly, from T-Rex, traffic is started from Linux PC and sent to Sonic network element, which is Sonic switch at Ethernet 4. So here the traffic from Linux PC is reached to Ethernet 4, and Ethernet 4 is the interface at which the sFlow agent is configured on switch using CLI sFlow config commands. Next, the Sonic switch is being monitored by sFlow-RT, which is running and installed on Linux PC. The sFlow-RT will be collecting the traffic stats data at Ethernet 4, which is sFlow agent, and sFlow-RT will analyze the network traffic, and the sFlow-RT will send the collected and analyzed network traffic stats to Prometheus in order to store the data collected by sFlow from Sonic Switch in real-time database. So here, when we are using Prometheus in order to store this sFlow collected data from Switch in real-time database. Next, Prometheus will send the Prometheus data, which is having the data in the form of matrices that is collected by sFlow in Grafana. So by using Grafana, we can see these matrices in different user-friendly dashboards. So as I said before, we are using sFlow Health Dashboard and sFlow Network Interface Dashboard here. To see the sFlow collected traffic network starts, we can access the web browser by giving the local host IP address where sFlow is running and default port 8008, so that we can see the sFlow collected data in the form of matrices that are collected from Sonic Switch in sFlow web browser. Next, we can access the Prometheus web browser by giving the localhost IP address where Prometheus is installed and running and the default port 9090. The sFlow sent data to Prometheus will be seen as a matrices in Prometheus web browser. So for that matrices, we can see the what type of network starts are there and what that can be viewed in the Prometheus web browser. In order to use the Grafana dashboard, or we need to access the web browser of Grafana by giving the localhost IP address where Grafana is installed and running and the default port 3000, so that we can use the different types of existing dashboards in Grafana. Hi everyone, my name is Purnima. I'm network engineer at Capgemini. The demo is about the update on Sonic project regarding network traffic monitoring. The presentation is about traffic analytics for Sonic network devices using sFlow. So in today's demo, I would like to discuss about demo objective, sFlow introduction, sFlow network monitoring setup, requirements mapping for sFlow RT and Grafana, monitoring setup configurations, quick note on challenges, and conclusion. Objective of this demo is how the network traffic is monitored for Sonic devices using sFlow service. Firstly, sFlow. sFlow is an application which is used to monitor Sonic network elements in real time and perform network analytics. The two main components of sFlow feature are sFlow agent and sFlow collector. Whereas sFlow agent, which is used for sampling network traffic and generating flow records from the sampled packets. Here, sFlow agent, which is configured in Sonic network element. Next, sFlow collector. sFlow collector, which is used to receive the data from sFlow agent and store the sFlow generated flow records. Next slide is about sFlow network monitoring setup, where the setup is made in a way there is a Linux PC. In Linux PC, we have installed network traffic generator, which is T-Rex. T-Rex will generate the traffic from Linux PC and transmits it to Sonic network element at Ethernet 4. And the tools, the sFlow monitoring tools that are installed in Linux PC are sFlow RT, Prometheus, Grafana. First, sFlow RT. sFlow RT is used to collect, store, and measure the network traffic from Sonic network element. Prometheus. The next tool is Prometheus. Prometheus is used to store the telemetry data in real-time database. The purpose of Prometheus is to store the data in real-time database. Next tool is Grafana. Grafana transforms the data into meaningful user-friendly dashboards. So here the setup is connected in a way in Linux PC. The T-Rex is installed and T-Rex will start sending the traffic from Linux PC to Sonic switch at Ethernet 4. The Sonic switch is being monitored by sFlow which is installed in Linux PC. Once T-Rex sends the traffic, it will reach the Sonic switch at Ethernet 4. The Ethernet 4 at Ethernet 4 on Sonic switch, which is the sFlow agent that is configured on Sonic switch. Now the sFlow will collect the data from Sonic switch at Ethernet 4. The board data will be monitored by sFlow and collects and stores the data of Sonic switch by using sFlow. sFlow will send these collected data of Sonic switch to Prometheus, where Prometheus will store this data in the form of real-time database, which will be in the form of matrices, and Prometheus will send this stored database to Grafana to see this data in the form of in by using the dashboards. So, in order to access the web browser of sFlow, we can access by using the localhost where sFlow is running, in which machine slot is running IP address and the default put 8008. Then we can see the slot collected data in the form of in the web browser. Next, in order to access the Prometheus web browser, we can give the local host IP address where Prometheus is running and default port 9090, so that we can see the matrices that are supported by sFlow that are seen in Prometheus, and we can see the corresponding representation of sFlow data in Prometheus. Next, Grafana. Here we are using currently we are using the existing dashboards that are supported by Grafana, Slotty dashboards that are supported by Grafana. So the dashboards are Slotty Health dashboard and Slotty Network Interface dashboards. In order to access the web browser of Grafana, we need to access by using the IP address where Grafana is running and default put 3000. The T-Rex traffic network generator, which is there in Linux PC, is sending the traffic, starting the traffic at Linux PC and sending the traffic to Sonic network element at Ethernet 4. So this we can do by starting the first we need to start the T-Rex server. For that we need to give the command, and we need to start the traffic by giving the command where the T-Rex configurations are done, traffic configurations are done, having the source address, destination address, and with the rate we need to mention. So here I am giving the rate as 1000, and then so in order to start the traffic from using T-Rex, we need to start. So now the traffic is started from Linux PC and it should reach to Sonic network element. So at Ethernet 4 it should reach. So now we need to configure the sFlow agent at Ethernet 4 on Sonic switch. For that we go to Sonic switch and show let's see the sFlow. So if we see the sFlow is down, the admin state and the configurations are not configured. In order to configure, initially the sFlow service will be disabled and will be in the mask mode. The sFlow service is in mask mode. We need to unmask the sFlow service and enable the sFlow service and start the sFlow service. If we try to config sFlow, we can see that it is failed due to sFlow service is masked. So first we need to unmask. The command to unmask the sFlow service is sudo systemctl unmask sFlow service. Now the service is unmasked. Next, we need to enable the sFlow service. Next, we need to start the service. Start the sFlow service. If we check for sFlow now, the admin state is set to up. The other configurations are polling interval, agent ID, and we need to configure the collector. Further, first we will be configuring the polling interval. The command is config sFlow polling interval. Here the polling interval is the time difference from agent to collector. Means within the time difference we have given, it will be sending the data from agent to collector. It will reach the collector. The data will be reaching the collector at that time difference. So here I'm giving 7 seconds. So the agent will send the data and the collector will receive the data within 7 seconds time difference. We check now sFlow. Yeah, it's updated to 7. Next, we need to configure the agent ID. sFlow agent ID, agent hyphen ID, and we need to add the agent ID. So here I am adding agent ID as Ethernet 4. So at Ethernet 4, I want to give the agent ID. We check for sFlow. Yeah, it's updated to Ethernet 4. Now we need to configure the collector. Config sFlow collector. Need to add the collector. In order to add the collector IP address, we need to give collector name. It's a random name. So I'm giving an testing as the collector name and IP address where sFlow is running. 72 dot. Check sFlow. Yeah, it's configured. Now all configurations are done for sFlow. Now the traffic is generated from T-Rex reaching the sonic network element at Ethernet 4. Now the Ethernet 4 is being monitored by sFlow RT. So for that we can for getting the accurate value, so I'm disabling all sFlow interfaces and only enabling the Ethernet 4 interface of sFlow in order to get only sFlow monitoring, Ethernet 4 monitoring. If we check for that, show sFlow interface. All sFlow interfaces are disabled on down. Now only Ethernet 4 is up. So now Ethernet 4 is being monitored by sFlow RT and sFlow RT will be collecting the data from Sonic switch at Ethernet 4. We can check the monitor data of sFlow Sonic switch using sFlow RT web browser. So for that, we need to access the web browser for sFlow RT. The IP address where sFlow RT is running and default port for sFlow RT is 8008. As we have given the agent ID in sFlow, Sonic Network element, which is having one agent. We can see in sFlow RT, the sFlow agent is 1, and at Ethernet 4, how many bytes of sFlow is coming and sFlow packets. So in this way, the sonic network element is being monitored by sFlow and the traffic that reached at Ethernet 4 is being monitored and collected by the sFlow. And we can see this collected data in sFlow web browser. So if you go to this, these are the installed applications by sFlow. In order to see what are the data, what is the data that been monitored by sFlow from Sonic network element is, we can go to browse metrics, and here if you see, we have configured the sFlow agent at Ethernet 4. If we check the IP address of Ethernet 4, we are having an 10.0.0.2. So if we check in sFlow, we can monitor the agent which is having the IP address 10.0.0.2. This is the sFlow agent that is being configured on Sonic network element. And these are the different matrices that are being monitored by sFlow from Sonic switch for Ethernet 4. If we give bytes in, the bytes in value for Ethernet 4 that is being monitored by sFlow is, we can see the graphs corresponding to the received data. Similarly, we can check different metrics, bytes out. Also, we can check back different matrices like these are the different matrices that are supported by Ethernet 4, and we can see these matrices using sFlow. Packets in, let us check for packets. Before I have given, I have started the traffic by giving the rate as 1000. So here for the packets in metric, when we are monitoring, it should show the value as 1000. So we are able to receive, we are able to monitor for the corresponding, for the generated traffic, we are able to receive the corresponding rate, and we are able to see the monitor data in sFlow, which is approximately 838. If we try with a different value, I'm stopping the traffic and starting with 500 and start the traffic. Let's monitor for 500. So traffic is sent with 500 rate. It will reach the Sonic switch. At Ethernet 4, it will be monitored, and the Sonic switch will be monitored by sFlow at Ethernet 4, and that data will be received by sFlow, and we are able to see that sFlow collected data here. So it's showing approximately 601. In order to access, now the sFlow is collected data, and we can see in the form of matrices. The sFlow will analyzes the collected data and stores the data. Now, if we go to Prometheus, the sFlow collected data will be sent to Prometheus, where it will be storing the data in the form of real-time database, and the sFlow matrices will be visible in Prometheus. In order to access the Prometheus, we need to give the IP address where Prometheus is running, which is the IP, and default port 9090. So this is the Prometheus web browser. So I'm giving sFlow whether we are able to see the collected data of sFlow in Prometheus. So these are the sFlow related matrices that are seen in Prometheus. So I'm considering the bytes in. If we see, I have registered to past last 5 minutes. sFlow bytes in at agent 10.0.0.2. So this is the monitoring in Prometheus. So in order to connect sFlowRT and Prometheus, we need to do the configurations in prometheus.yaml file. For that, let me show you. So firstly, when we want to use sFlowRT, and sFlowRT need to connect with Prometheus, so that we have to do one configuration, which is sFlowRT.configuration file. So in this file, I am adding an exporter, which is the type Prometheus. Means I want to, in sFlowRT, I want to connect to Prometheus, which is having the IP address and the default port 9090. I want to connect with that Prometheus type. So that we are mentioning in sFlowRT configuration file. If we do this configuration, we can whatever the sFlowRT details data will be there, that will be reaching the Prometheus. There will be connection. Now, the configurations that are done in prometheus.yaml file is the path where prometheus.yaml file would be Prometheus, and there is an prometheus.yaml file. So the configurations will be in a format where it will be having job name. Job name is the job name is the metric what we want to support. I mean, in Prometheus, we want the Prometheus to have the sFlowRT collected data. So I'm adding the job name as sFlowRT and the metric path and the target, which is having where this sFlowRT service is running, which is the IP address and local default port 8008. So in this way, these are the sFlowRT configurations that are done in Prometheus YAML file, prometheus.yaml file, in order to visualize the matrices that are supported by sFlowRT in Prometheus. So the sFlowRT collected data now in the form of matrices will be stored in Prometheus in a database, in a real-time database. So if we see next, the Prometheus will send the data to Grafana to see these collected matrices, the flow of matrices that we can see in Grafana using dashboards. For that, in order to access the Grafana web browser, we need to give the localhost IP where Grafana is running, which is 172. So this is the IP where Grafana is running and the default port 3000. Now, if you see, let me show you what are the configurations that need to be done on Grafana in order to connect with sFlowRT and Prometheus. So when you open, this is the page which is the Grafana web page. So here we need to add the first data source. We need to click this, and the data sources from Prometheus. We are collecting the data that I'm mentioning by giving the option Prometheus. And here we need to give the Prometheus server link, which is localhost where Prometheus is running and default port. So that Prometheus and Grafana will be connected and the Prometheus data will be seen in Grafana. And default port is 9090. After giving this, we need to save and test. If the IP and if the IP of Prometheus is correct, we can successfully query the Prometheus. So now it's successfully queried. The next step is, now we have added the data sources Prometheus. The next step is we need to import the dashboard. In order to import dashboard, we need to click this plus symbol. We'll be having the import dashboard option. And here we currently we are using the existing dashboards, existing sFlow dashboards. So in web browser we can see the what are the sFlow existing dashboards currently there in Grafana. For that, Grafana Labs dashboard. This is the website where it will show the different types of dashboards that are supported by Grafana. So we are considering sFlow dashboards in Grafana. So I'm checking for sFlow. So these are the sFlow supported dashboards by Grafana. So if we want to import this dashboard, so here I'm importing the sFlow health dashboard. So this here we can see, right, there is an option copy ID to clipboard. So if I copy this ID, and these are the configurations that need to be done in prometheus.yaml file. Before, as I mentioned, so we have done some configurations in prometheus.yaml file. So these also should be added in order to support this sFlow health dashboard. And if we add these configurations in prometheus.yaml file, the corresponding dashboard will be showing the data of Prometheus in Grafana. I'm copying this. And here we need to give the copied ID of, so here we have copied the sFlow health dashboard ID, and we need to load. So we can see that the name of the dashboard is sFlow health. So here the data source we have given is Prometheus. So I'm giving Prometheus and then import. Yeah. So here it's showing for last 6 hours. I'm changing it to 15 minutes. So yeah, we can see that the sFlow agent is one where so this data which is there in sFlow is now connected to Grafana, and we are able to see the sFlow data in Grafana. sFlow agent as one. sFlow agent as well. But the difference is there we are able to monitor the data, and here we are able to monitor data using some graphical view, and we can visualize the how the flow is, whether it's going down or up. We can see the difference, and it is easy to understand what is the percentage, what is the value we have received, what's the current value. We are able to observe using Grafana dashboards. So this is the use of using Grafana dashboard. So in this way, when traffic is generated at T-Rex, which is there in Linux PC, it's reaching to the Sonic network element at Ethernet 4. The Ethernet 4 is being configured as sFlow agent, and as the Ethernet 4 is being monitored by sFlow. sFlow will monitor, will collect the data of traffic generated from T-Rex. and it will store the data and send it to Prometheus, where Prometheus will store the data in real-time database, and it will analyze the traffic, and it will be sending this traffic to Grafana in order to see the visualization of that monitored data in the form of these user-friendly dashboards. So this is the flow, how traffic is generated and how the traffic is monitored using sFlow. T-Rex, we are able to start the traffic, and the T-Rex is reached to Sonic switch, and from Sonic switch we are able to monitor the traffic using sFlow tools, network monitoring tools by sFlow, and where sFlow is collecting the network traffic data and sending to Prometheus, where we can see the data of sFlow in the form of matrices, and finally we can see the metric graphs in Grafana. So for this we have to do some configurations with respect to Slot and Prometheus, which are so these are the configurations that need to be done with respect to Slot and Prometheus. Firstly, in Slot, when we installed, we will be having a path which is user local sFlow.config.t, and there will be a file which is sFlow.config. So in this file we need to mention that we are using Prometheus. So in order to add that, we have to give it as an exporter, and the type we are using is Prometheus, which is having the host IP as the IP, which is the IP address where Prometheus is running, and default port. This configuration need to be added in sFlow.config file in order to use the Prometheus. Now, the Prometheus configurations that need to be done is, once we install, then we can get the link. Get the we can locate this where etc Prometheus, and there will be a Prometheus.yaml file where we have to do the configurations. So these are the configurations that are done in Prometheus.yaml file in order to receive the sFlow data. Means we want to use the sFlow data. The collected data in sFlow should be seen in Prometheus. So for that we have to include in Prometheus that we want to receive the data of sFlow, that we can achieve by giving the job name, these configurations, so that we can see the sFlow data in Prometheus, which are collected from Sonic network element. So here job name is sFlow. That means we want to get the data of sFlow, which is having the path and target where sFlow is running and where sFlow is received the data, which is the local host IP address and default port 8008. These are the different sFlow related collected data from Sonic network elements. So we want to see these different sFlow metric values in Prometheus. That's why we are adding these configurations in Prometheus.yaml file. So with respect to sFlow, I have added the jobs which are sFlow analyzer, and sFlow source destination BPS. Also sFlow source destination, this is sFlow flow source destination BPS, and the difference is here the sFlow source destination BPS. So these are the configurations that are done in Prometheus.yaml file with respect to sFlow, and these are the requirements. These are the matrices that are supported in sFlow and Grafana. Based on that, we have given whether they are supported or not. So here the matrices are packets in, packets out, bytes in, bytes out, errors in, errors out, and utilization. Whether they are supported in sFlow, whether we are able to see them this metric in sFlow that we mentioned, and Grafana, whether So here we are using existing dashboards. So whether the existing dashboards are having these matrices or not, we have mentioned it. And finally, the challenges we faced are when we have added the configurations of sFlow in Prometheus.yaml file. Firstly, initially we have added the IP address as localhost and default port as 8008 in order to receive the data in the form of matrices in Prometheus. But we could not receive the data even though we have added the configurations in Prometheus.yaml file. We are unable to see the configurations in Prometheus web browser. So finally, we have resolved this issue by giving the local host as the IP address where sFlow is running and where sFlow is receiving the data from sonic network element. That IP address we have given and the default port is 8008. Then we are able to receive and see the configurations in web browser and able to see the matrices that are supported by sFlow. So these are the challenges we have faced, and the conclusion is we are able to monitor network traffic using sFlow in Sonic Switch. End-to-end monitoring is successful, and by utilizing the tools sFlow, Prometheus, and Grafana, we are able to capture the network traffic, store it, and visualize the network performance. And we are able to get the network behavior of what type of traffic it is, and uh, information regarding the traffic using the sFlow monitoring. Thank you, and thank you everyone. The next slide is challenges faced while setting up sFlow monitoring. Initially, we are not sure on how to use the Prometheus, so we discussed with the team and explored further references. We followed the Prometheus knowledge base on how to connect the Floaty and how to receive the data. So for that we have followed the knowledge base of Prometheus, and next we have configured the Prometheus to collect Floaty matrices, which we have done in Prometheus.yaml file. Like in Prometheus.yaml file, we have added the job configurations of Floaty. uh, Initially in the job configurations we have given the local host and port 8008 for sFlow matrices, but we are unable to receive the sFlow data in Prometheus. Like in configurations we are able to see, but in Prometheus web browser we are unable to get the sFlow collected matrices in Prometheus. So finally, we resolved this issue by giving the local host as the IP address where Prometheus sFlow is running, and that IP address we have given in the sFlow matrices of Prometheus.yaml file. And then this issue got resolved, and finally we are able to see the matrices that are having the data in Prometheus web browser. So these are the challenges we have faced. And the conclusion, the next slide is conclusion. We have successfully able to monitor the network traffic monitoring using sFlow, and by utilizing the sFlow, Prometheus, and Grafana tools, we came to capture the network traffic data, store and visualize the network performance in real time. And by using this monitoring we able to get the network behavior and the issues, and what are the issues and the network performance. We are able to monitor this and get the data of this. Thank you. Thank you.